by popular demand, we dive into building with room modules. Before we dig deep into the subject, let's clarify what sets 3D room modules construction apart from other methods. Unlike traditional construction, which is often thought of in 2D layers, floor by floor, 3D room module construction considers each module as a three-dimensional element. Imagine it like building with blocks, but each block is an entire room or functional area, complete with walls, floors, and sometimes even furnishings and fittings. 3D room module construction is a method that leverages prefabrication and modularity to revolutionize how we think about building. Let's delve into its intricacies. From a design standpoint, you have modules that can vary in shape, size, and function, opening doors to creative and efficient use of space. What does a module consist of? As a rule, room modules are mostly cuboids, with rectangular floor plans and 6 boundary surfaces, of which 2 each have the same size. In constructional terms, one distinguishes between longitudinal walls, transverse walls, the ceiling, roof, and the floor. From a conceptual as well as a production-related and logistic perspective, all 6 sides are ideally closed. However, this is only the case when one utilization unit coincides with the dimensions of one room module, as in applications such as hotel rooms, small flats, or student residence complexes. Here we visited the room module prefabrication at the Groot Vroomshoop in 2022 for a temporary school in Amsterdam. Different configurations of modules for the same building. Breaking from conventions, let's look at this project by Starblock, where modules were designed to span vertically across 3 floors. It's not just a feat of engineering, but also a masterpiece of space utilization. By thinking vertically, the architects were able to maximize spatial efficiency in a way horizontal modules could not. Each module is a self-contained structural unit designed to bear its own weight. The interlocking systems are engineered to distribute loads effectively across the assembled structure, providing robustness and resilience. The modules come with a sealed envelope, providing a controlled internal climate, which is an added advantage in terms of sustainability and occupant comfort. When we talk about speed and efficiency in space module construction, we are referring to 2 factors: reduced construction time and assembly line production quality. The prefabrication process allows for a level of quality control that is hard to achieve with traditional construction methods. Now imagine a linear timeline. In traditional construction, site preparation is a prerequisite to building. Only after permits are secured and the site is prepared does the actual building begin. By step sequence adds to the project timeline. Now, consider module construction. Site development and foundations happen simultaneously with off-site module building. This parallel process trims down the timeline significantly, giving modular construction a quicker turnaround. The assembly and site restoration also are significantly reduced in this way. Reports indicate that modular construction can be 30 to 50% faster. The implications here aren't just about speed, but also as cost effectiveness and reduced environmental impact. While prefabrications offers speed, it also brings logistical complexity. The coordination of manufacturing, transporting, and assembling the modules is akin to a well-orchestrated symphony. Each step must be meticulously planned for the project to proceed smoothly. Additionally, integrating services like plumbing and HVACs is a complex task that requires upfront planning. Transportation can also be a constraint for the module. Dimensions and leads to the design being often restricted to the module's box-like form. Another concern is that the stiffness needed for the transportation of the modules during transport could be higher than the building actually requires, causing a potential overdimensioning of material. Hotel Jakarta, situated in Amsterdam, serves as an exemplary case study in 3D room module timber construction. 176 out of 200 rooms are entirely modular. Each room is a 30 square meter space, pre-equipped and delivered on site for plug-and-play construction. Let's zoom in on the construction details. The base is formed by the underground car park and the reinforced concrete structure of the ground floor and first floor, with stabilizing elements, the staircases and lift shafts. The wooden modules rest on this base and leave open a lush green atrium, surrounded by the circulation walkways clad in laminated bamboo. The architects faced the challenge of marrying structural needs with design aspirations. In the module, they combined prefabricated concrete floors with cross-laminated timber walls and ceilings. This hybrid approach achieved both structural integrity and aesthetic quality. Each of these rooms was delivered to the site completely, fitted, down to the passive facade, balcony, and even a fully equipped bathroom. Every unit could fit on a standard truck, ready for plug-and-play upon arrival, including all technical installations and finishes. Imagine this: 176 prefabricated wooden units, each 30 square meter, were placed on site within just 3 weeks. They reached a height of 30 meters above the gaze of Java Island. The speed of construction here is a real-world illustration of the benefits we discussed earlier. In summary, 3D room module construction is an evolving field offering speed, efficiency, and a certain level of design flexibility. However, its success hinges on rigorous planning, from logistics to structural engineering and service integration.